First, let's draw the external forces acting on this system. First, we have to draw the external forces acting on the system. A free body diagram. A free body diagram means that you have to mark all the external forces acting on the objects that you consider. Weight is the external force. Here it's 60 newtons. And here the mass is 4 kg. So the weight is the external force. It's 40 newtons. When an object touches the surface, there's a normal reaction force created on the object by the surface. It's R. Angle here is 30. So here you will have an angle 30. Weights are marked, then the normal reaction marked. Then you have to mark the tension. Okay, tension force attracts the connected point towards the string itself. Tensional force attracts the connected point towards the string itself. When the string passes a pulley, tensional force attracts the connected point of the pulley towards the string itself. Tensional force attracts the connected point of the pulley towards the string itself. Okay, so it is the 4 tensional forces that we have to mark. Okay, don't worry about these 2 tensions. Even though we mark them on the string, these tensions are the forces acting on the pulley. Why? Even though we mark the tension of the string on the string, on that line, still the tension is the force acting on the objects that is in touch with the string. So this is the force acting on the pulley. This is also a force acting on the pulley. So we don't need them to apply. We don't need these 2 tensions to be used in our equations, but we need these 2 tensions. Why? 6 kg mass attracted towards the string itself and 4 kg mass attracted towards the string itself. Tensions are marked. A free body diagram means the forces, the external forces acting on the objects that you consider. Tensions, normal reaction, weight is marked. And in their paragraph, they say 6 kg is moving down. To move down, the string has to pass the pulley in this way, and 4 kg has to move up with a common acceleration A. This is moving down, this will move up. As this is moving up, friction will be created in the opposite direction to this direction. Okay, so it is the first part. You have to mark the free body diagram, mark the external forces acting on these objects. Second one, you have to find the friction. Friction is equal to mu r when the object is in the motion. Mu, the frictional coefficient is 1 over 2 root 3. You have to find the r value. There's no any perpendicular motion. There's no any perpendicular motion to the plane. This 4 kg mass moves on the plane. This 4 kg mass moves on the plane. There's no any perpendicular motion. So r should cancel out with the perpendicular force in this direction. You have to take the 2 components. To this direction, it's 40 cos 30. 40 cos 30. To this direction, it's 40 sin 30. 40 sin 30. This 40 Newton force is in a separate direction towards Earth. So you can't use it in this or this direction, keeping it in a raw manner like this. You have to consider the components. 40 cos 30, 40 sin 30. Now 40 is already denoted by these 2 components. You can leave 40. These 2 are there. And you can see r is perpendicular to the plane in the upward direction, and 40 cos 30 is perpendicular in the opposite direction. As there's only a motion parallel to the plane, these 2 forces should cancel out. R will also be equal to 40 cos 30. R is also equal to 40 cos 30. They will cancel out from opposite directions. So R is equal to 40 cos 30. You have to write. Consider the vertical plane to the inclined plane. No any motion. The vertical plane to this inclined plane does not show a motion. The object only moves parallel to this inclined plane. So R should value wise get cancelled with 40 cos 30. So R is equal to 40 cos 30, root 3 over 2, 20 root 3. So what will happen? I will substitute R here, 20 root 3. So root 3 will cancel out. Frictional force is equal to 10 newtons. Number 2. Question number 3. I had to find the common acceleration. Applying F equals ma for the 6 kg mass in the downward direction. When applying F equals ma to the 6 kg mass in the downward direction, this F is the resultant force acting on the system. So 60 minus T. 60 minus T is equal to 6A. First equation. And applying F equals ma for the 4 kg mass parallel to the plane in upward direction. As I'm applying F equals ma for this 4 kg mass parallel to the plane, vertical forces to the plane will cancel out. Cancel out means they are not used. Why? The perpendicular vectors does not affect the plane that we are dealing. If the vectors are perpendicular to the plane that we are dealing, they will not affect our equations. Okay. So R and 40 cos 30 is, I don't need to consider them. I have to consider the resultant external force parallel to the plane in the upward direction. T minus 40 sin 30 minus friction. T minus 40 sin 30 minus friction is equal to 4A. T minus 20 and friction is 10 is equal to 4A. It's the equation B. I'm adding these two equations, A plus B. 60 minus T from here plus T minus 30 is equal to 6A plus 4A. T will cancel out. 30 is equal to 10A and acceleration is equal to 3 meters per square second. Okay, that's the part 3. Then part 4. Find the distance traveled by the 4 kg block on the table by the time 6 kg block reaches the ground. By the time the 6 kg block reaches the ground, it has to move 1.5 meter down. Now, you can explain it by a simple sentence. This string is inextensible. This string is inextensible. So what will happen? If this end of the string comes 1.5 meter down with the 6 kg mass, other end of the string, it has to move up from a 1.5 meter distance carrying 4 kg mass at its end. So 4 kg mass will also reach a distance 1.5 meter up parallel to the plane. Why? String is inextensible. If one end moves from 1.5, other end also has to move from 1.5 carrying the object connected to that point. Okay. So the 4 kg mass will also move 1.5 meter up the plane. Okay. Question number 5. Calculate the velocity of 6 kg block just before it hits the ground. Applying V square is equal to U square plus 2AS for the 6 kg block. When the 6 kg block hits the ground, its velocity square is V square. It starts from rest to a common acceleration is 3. It has to move 1.5 meter down. When it reach 1.5 meter down with this common acceleration, it will hit the ground. V square 0 at the beginning, 2A acceleration 3, 1.5 meter down. V square is equal to 9 and V is equal to 3 meters per second. So here, when the 6 kg block hits the ground, it will have a velocity of 3 meters per second. Velocity of 3 meters per second. Now, when the 6 kg block comes to the ground, the string is also there. So, as it's an inextensible string, other end, it's in a position where it has reached 1.5 meter up. Okay, so 4 kg mass is somewhere here with the 1.5 meter distance up the plane, and the string will start from here and other end, it will reach 1.5 meter up. Okay, so 4 kg mass is somewhere here with the 1.5 meter distance up the plane, and string will start from here and other end, the string will start from here and the string will start from here. And the string will start from here 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 and the string will start from it's already in the ground with the 6 kg mass with a velocity of 3 meters per second. Okay. Part 6. Part 6. Describe what happened to the tension in the string immediately after 6 kg block strike the ground. Explain the reason. After this 6 kg block strikes the ground, not only the 6 kg mass, due to the acceleration, this also is with the velocity. Let's say v. So the string can't move further down. It's already in the ground. But from the other end, 4 kg mass has a velocity, so it will move up on the plane. What will happen? String will lose its tension. String will lose its tension. It will no longer in a taut condition. Taut condition එකක් කියන්නේ TAUT. Taut condition එකක් කියන්නේ ඇදිලා තියෙනවා. තවදුරටත් එයා ඇදිලා නැහැ. It's no longer in a taut condition. It will lose its tension. If the string is not in a taut condition, there's no any tension. It will lose its tension. Okay? When the 6 kg mass hits the ground, not only is the 6 kg mass, 4 kg mass is also having a velocity due to the previous common acceleration. So 4 kg mass will tend to move further up with the velocity it has gained. When 4 kg mass is moving up, the string is released from that side. But it can't move further from this side as it's already hit the ground. So what will happen? The tension will lose its taut condition. ඇදිලා නැහැ. තන්තුව බුරුල් වෙලා යයි. ඒ මෙහෙන් ඉස්සරහ උඩට එනවා. මෙහෙන් තව යන්න තැනක් නැහැ. මෙහෙන් තව යන්න තැනක් නැහැ. එතනම තියෙනවා. මේ පැත්තෙන් උඩට එනවා. තන්තුව බුරුල් වෙලා යයි. Tension will lose its taut condition, and due to that, the tension of the string will become 0. Okay? And question number 7. After the 6 kg block hits the ground, the 4 kg block continues to move. We know that. Find the maximum distance the 4 kg block travels on the table before coming to rest. Also calculate the time taken to reach this position. Okay, that's a very important part. Now, I'm going to erase these things. I'm going to erase the board. Now, let's discuss what happens after this. Now, let's discuss the situation after this. Let's discuss the situation after this. When this 6 kg block reaches ground, passing a 1.5 meter distance, as the string is not a extensible one, as it's inextensible, this 4 kg will also move 1.5 meter up the plane. Applying V square is equal to U square plus 2AS for the 4 kg up the plane. 4 kg has started from the 0 velocity. Initially it was at rest. It will also have this common acceleration A. 2 acceleration is 3, and it will also move 1.5 meter up the plane, and it will gain the velocity V. V square is equal to 9, so it will also have the velocity value 3 meters per second. So it will also have the velocity value 3 meters per second. This hits the ground with the common acceleration, gaining a velocity C, the same common acceleration. So same 1.5 meter distance. This will also gain a velocity value 3. This will also gain a velocity value 3. Now, I will draw the next condition. Now, this 4 kg mass, has a velocity of 3 meters per second due to the previous common acceleration when it was going up. And the tension is no longer in a taut condition. Why? As soon as this one reaches 1.5 meter up the plane, this hits the ground. It can't go further down, even though this has a velocity. So it moves up, leaving the tension of the string, leaving the taut condition of the string. It's on the ground. Okay. Now, as there's no any tension, you can't mark the tensional force. T is 0 now. But here, the weight is 40. So the normal reaction is present. When object touch the ground, normal reaction is present. If the angle here is 30, here also you have an angle 30. So to this direction, it's 40 cos 30. They are still present. To this direction, it's 40 sin 30. Now look carefully. Earlier, when we apply F equals ma at the previous situation, how I applied F equals ma? T. Why? The tension attracted the 4 kg mass up the plane. T minus weight component minus friction. But now there's no T. But still, as the velocity is there, it tends to move up. As it tends to move up, the friction will occur. Friction is also present. Why? It's having a velocity. It was in a motion, and now also it's with this velocity. So it will move further. Even the tension is not there now. Still the velocity gained by the previous acceleration is present. So what will happen? It will try to move up. It will move. When it's moving, friction is still alive. Friction will be there to the opposite direction. So friction is present. Weight component is present. Only absent force is the tension. Okay. Applying F equals ma again up the plane. Applying F equals ma up the plane after T equals to 0. So what are the upward forces now? 0. So this F should be the resultant force acting on the mass in the considered direction. Is there tension? No, 0. Minus, to the other side, there's a 14 sin 30, 40 sin 30. Minus friction is equal to 4. The new acceleration is A dash. Acceleration will change from here. Why? The forces are changed. Okay. So as soon as this hits the ground, this 4 kg mass still move up due to the velocity that it has gained, and it will bring the tension into a zero tension stage as it's no longer in a taut condition. Okay. Now again, this force setting is changed as the tension is 0 now. So I have to apply F equals ma again to find the new acceleration. What are the forces? If there's no any upward force, T is 0. Down the plane, 40 sin 30 is there. As the movement is in the up direction with the velocity, friction will be in the opposite direction. Fg is minus, is equal to 4. The new acceleration up the plane is A. Vertical forces to this plane are neglected, R and 40 cos 30, as in the previous. Okay, 0 minus 40 sin 30 is 20 minus friction. But can you notice friction will not change its value? It's 10. Friction will not change its value. It's 10. Why? If the friction will change, if the frictional coefficient change, it hasn't changed. Friction will change if R changes. It hasn't changed. Why? All the things happening in this all the things are happening parallel to the plane. Perpendicular to the plane, nothing special. It is the same manner as earlier. To this direction, 40 cos 30. To this direction, it's R. They are not moving in a vertical plane to the inclined plane. So there's no any motion in the vertical plane even in this situation. So R should cancel out with 40 cos 30. So R will have the same value 40 cos 30, and the frictional coefficient is also having the same value. So the friction won't change. It is 10 again. You have to understand that. Now this is a separate situation. Tension is 0. So acceleration has changed. Now we are finding it. But vertical to the inclined plane, nothing has changed. 40 cos 30 to this direction, R to the upward direction. And again, there's no any motion in the perpendicular plane to the incline. So R should cancel out with 40 cos 30 while having the same value. So friction value will be remaining same, 10. Applying F equals ma upward, 0 minus 40 sine 30 minus 10 is equal to 4a dash. 4a dash. Minus 30 is equal to 4a dash. A dash is equal to minus 7.5 meters per square second. Now, after the tension is lost, when the string is no longer in a taut condition, due to the previous velocity gained 3 meters per second value, as the new acceleration, 4 kg mass will receive point minus 7.5 meters per square second acceleration. It's a deceleration. It will slow down. A is minus, it's a deceleration. It will slow down. Why? There's no any tension to move it with the acceleration upward. All the remaining forces are in the opposite direction. So the velocity will, this 3 meters per second velocity will drop with the time, with the deceleration of 7.5. So that's the situation. And find the maximum distance 4 kg travels on the table before coming to rest. Okay, now applying applying v square is equal to u square plus 2a from here to the maximum point that this 4 kg will reach. At this point, 4 kg will have a zero velocity. At this point, 4 kg will have a zero velocity. What is this distance? S. Applying v square is equal to u square plus 2as. Due to the previous acceleration, now 4 kg has an initial velocity of 3 to start this new situation, 2. But in the new situation, as there are no any upward forces on the direction parallel to the plane, as this 40 sine 30 and friction are in the opposite direction, velocity will be dropped with the deceleration of 7.5. That means acceleration is minus 7.5. How long it will travel? It will travel for a distance s. It will travel for a distance s. And what will be the final velocity? 0. Okay. 2 into minus 7.5 s. 15 s is equal to 9. S is equal to 9 over 15 meters. 9 over 15 meters. So, after string loses its tension, due to the velocity gained by the previous acceleration, 3 meters per second value, and with the new deceleration, minus 7.5 meters per second, 4 kg block will move another 9 over 15 meter length on the plane in the upward direction. Okay? And calculate the time taken to reach this position. Apply v equals u plus at to this part. V equals u plus at. When it comes to rest, final velocity 0. It's having a velocity of 3 due to the previous acceleration when starting this new motion. Acceleration for the new motion is minus 7.5 equals u plus at. Time is t. To become the final velocity 0, initial velocity 3 minus 7.5 t. 7.5 t is equal to 3. T is equal to 3 over 7.5 seconds. 4 kg will move for another 3 over 7.5 seconds time, passing 9 over 15 meter length, and will come to rest for instantaneous rest. It will come to instantaneous rest. Show that after this 4 kg block moves downward with a constant acceleration of 2.5 meters per second. Okay. After this position, what will happen next? After this position, what will happen next? After this position, what will happen next? I have to draw the image again. Now, this 4 kg mass in a higher position, string is definitely in a situation where there's no any tension. and velocity is also 0. No tension. But what happens after it comes to rest? Now, due to this 3 meters per second velocity, even the tension is 0 as there was a velocity until it comes to rest. Even though there are some opposite forces, with the deceleration, it went up. Now, it's in a rest for instant, but still 40 sine 30 is in this direction. It's the gravitational cause. It is the gravitational call. It's always there, 40 sine 30. Weight component. It's always there. So what happened? Even after it's at rest, this 40 sine 30 will try to bring the 4 kg mass downward again. As it tries to move down, friction will bond in the opposite direction. Friction will bond in the opposite direction. Its value will become 10 again. To change friction, mu might change. It's not change, it's same, it's the same surface, or R have to change. R will not change. Why? Vertical plane does not affect by any kind of a situation that we are dealing. Vertical plane is not affected. Vertical plane to this inclined plane, to this direction, they have R. To this direction, they have 40 cos 30. All the motions are parallel to the plane. So again, 40 cos 30 will cancel out with R. So R will have the same previous value. With multiplication from mu, friction will have the same value. It's 10 again. But this time, friction is in a upward direction. Why? After coming to rest, 4 kg will be there at rest for a certain instant. Meantime, 40 sine 30 is asking to go back. It's always attracting the object to this side. So it will tend to move in this direction with a double dash acceleration. As it tries to move in this direction due to 40 sine 30, as it's a instantaneous rest also, it's in an instantaneous rest, and again 40 sine 30 is calling him, so he will tend to move downward. It will create the same valued friction in the upward direction. So let's apply F equals ma down the plane. 40 sine 30 is down the plane minus friction up the plane 10. Mass is 4. New acceleration is a double dash. 40 sine 30 is 20 minus 10 for a double dash. 10 is equal to 4a double dash. New acceleration is 2.5 meters per second. New acceleration is 2.5 meters per second. Okay. This is the situation. This is a very good question. I think if I'm correct, I took this question from the term test. Term test paper. It's from Visakha College, and I can't remember the year. I can't remember the exact year. I took this from Colombo Visakha College term test. First term test. Okay. Visakha එකේ first term එකේ වලට එන්න තියෙන term එකේ ප්‍රශ්නයක් මම මේ ගත්තේ මට අවුරුද්ද නම් පුතා මතක නැහැ. හරි. ඔන්න ඕකයි වැඩි. So this is the situation. Okay. Now it came to an instantaneous rest after the 3 meters per second velocity decreases up to 0 due to the opposite forces, and as there was no any tension to move it up with the acceleration, as string lost its tension. As the other two forces are remaining, it got a deceleration up the plane from the point where string lost the tension. It was a minus 7.5 value. With that value, it moved another 9/15 meter length up with the in a time 3/7.5, and its velocity became 0. Now I'm moving to this picture. Now it's in an instantaneous rest and tension is no longer there. And 40 sine 30 is calling back and it tends to move down. So immediately friction will change its direction, and as the motion is in this direction, friction will bond to the opposite direction. The value will not change, it's steady. R and mu will not change. So 40 sin 30 minus 10 is equal to 4a. So again, this will come down with the acceleration of 2.5 meters per second. Okay, then determine the time for which 4 kg block continues to move during this stage. Okay, can you remember? This is the position. This is the position where this string lost its tension, where it became to a non-taut condition. ඇදිලා නැති අවස්ථාවකට non-taut condition. So it's 1.5 meter up the plane from that special point. So it will come down for another 1.5 meter length. It will come down for another 1.5 meter length. Then again, when it comes down for another 1.5 meter length, it will be in this position. This was the position where the string lost the tension. But now the tendency is to move down, and string is in the perfect position, even though it doesn't have a tension yet. Now its complete length is active. What will happen? Due to the velocity gain with this acceleration, this will try to move further down the plane, and what will happen? The string will align to a taut condition again, and this will try to move up. Okay, a new situation will occur. එක නේද වෙන්නේ? මොකද වෙන්නේ? දැන් මෙයා මෙතන මීටර් 1.5ක් උඩට ගිහිල්ලානේ මෙතෙන්ට ඇවිල්ලා velocity 0 කරගත්තා. ඊට පස්සේ මේ අලුත් condition එක හින්දා යාට 40 sin 30 වලින් call කරන හින්දා tension 0 හින්දා friction එක අනිත් පැත්තට හැදුණා වුණත් acceleration එකක් ඉතුරු වෙලා 2.5 meters per square second. එයා ආයෙ පල්ලෙහාට එන්න ගන්නවානේ. එයා ආයෙ 1.5 meter පල්ලෙහාට මෙතෙන්න එනකොට අර එයාගේ ටෙන්ෂන් ස්ට්‍රිං එකේ ටෙන්ෂන් එක නැති වෙච්ච කන්ඩිෂන් එකම ආයෙ අනිත් පැත්තට හැදෙනවානේ. මොකද මේ තැනදීනේ කලින් වටේ ස්ට්‍රිං එක බුරුල් වෙන්න ගත්තේ. මෙතනින් වඩා උඩට යනකොටනේ මේ පැත්ත වැදිලා හින්දා ඔල්රෙඩි ස්ට්‍රිං එක බුරුල් වෙන්න ගත්තේ. මේ පැත්ත ඔල්රෙඩි මෙතන බිම වැදිලා හින්දා මෙතන පන්නන් උඩ යනකොටනේ ස්ට්‍රිං එක බුරුල් වෙන්න ගත්තේ. එහෙම පන්නගෙන උඩ ගියේ දුරනේ 9/15. ඉතින් 9/15 ආයෙ එනකොට මේ තැනනේ. එතකොට ස්ට්‍රිං එක හරියටම ගානට සෙට් වෙලා ඉන්නේ. හැබැයි velocity එකක් තියෙනවා. ඒ නිසා මොකද වෙන්නේ? මෙයා තව පල්ලෙහාට එන්න බලයි. හැබැයි string එක හරියම length එකේ ඉන්නේ දැන්. ඇඹරිලා නැහැ, පැටලිලා නැහැ. දිග අර බුරුල් වීම ඇරිලා තියෙන්නේ. මේ velocity එක මෙහෙට තියෙන හින්දා මේ පැත්තෙන් ඉස්සේ මෙහෙටනේ මෙහෙට ඇදිලායි. හරි. Okay. So ninth part, determine the time for which the 4 kg block continues to move during this stage. It's for 1.5 meter distance. Applying S equals ut plus half at square. Here it was in an instantaneous rest 0. Half acceleration is 2.5 t square. T square. It has to come again for another 9/15, not 1.5. Another 9/15. Not 1.5, another 9/15 distance to this direction. 1.5 කියලා කියුනේ වැරදිලා. හරි. මොකද උනේ? මෙයා පොළවේ වදිනකොට මෙයා යම් පිහිටීමක හිටියානේ. මුලදී මෙයා 1.5ක් එද්දි මෙයා උඩට 1.5ක් ආවා. ඒක හරි. ඊට පස්සේ මෙයා පොළවේ වදිනකොට මෙයා යම් පිහිටීමක හිටියානේ. ඒ වගේම මෙයාට හම්බ වෙච්ච velocity එකක් තිබ්බනේ. ඒ velocity එක හින්දා දැන් මෙයා තව උඩට යන්න හදනවා. එහෙම යන්න හදන අතරේ හැබැයි දැන් ලනුව බුරුල්නේ. ඒ නිසා මෙයා තනියෙන් උඩ යනවා. එතකොට මේ opposite forces හින්දා එයා deceleration එකක් face කළා -7.5. ඒ නිසා එයා velocity එක 0 වෙනකල් 9/15 තව උඩ ගියා. එතනදී එයා instantaneous rest එකකට ආවා. හැබැයි දැන් ලනුව කොහමත් බුරුල්. තාම 40 sin 30 වලින් කතා කරනවා friction එක අනිත් පැත්තට. අලුත් acceleration එක 2.5 වලින් එයා අර ගිය 9/15 දුරම ආයෙ එනකලුත් ඕක කොහොමම තියෙයි. ඊට පස්සේ මෙතන මේ velocity එක හැදිලා තියෙන හින්දා string එකත් ආයෙ perfect condition එකට ඇවිල්ලා හින්දා ඇඹරුම ආයෙ ලෙහිලා හරි දිගට ඇවිල්ලා හින්දා අර වැඩිපුර ගිය ටිකනේ ආයෙන්නේ. ඊට පස්සේ මේ velocity එකෙන් මෙයා මෙහෙට ඇදෙනකොට මෙහෙන් ඉස්සේ condition එක වෙනස් වෙයි. ඊළඟ ඒ අලුත් condition එකට එන්න කලින් 9/15 පහලට එනකල් මේ දේවල් තියෙයි. distance එක 9/15 from instantaneous rest u0 half acceleration is 2.5 t square. From there you can calculate the t related to the 9th question. Determine the time for which the 4 kg block continues to move during in this stage. Question number 10. Find the total time interval for which string remains without tension. Find the total time interval for which string remains without tension. Okay. From here to here, string doesn't have a tension. From here to here, string doesn't have a tension. It's equal to 3/7.5. And again, until it reaches from here to here, it doesn't have a tension. This answer should also be here. And you will get the final answer. You will get the final answer. හරි නේද? මෙයා මෙතන ඉඳලා මේ උඩට යන කලුත් ස්ට්‍රිං එකට ටෙන්ෂන් එකක් නෑ. අන්තිම 9.9/15 meters ගිහිල්ලා අර මේක පොළවේ වදිනකොටම මෙයා හිටපු තැන අනුව දැන් තව මෙහෙන් පල්ලෙහාට යන්න බැරි හින්දා මෙහෙම නිකන් තනියෙන් උඩ ගිහලා අනුව බුරුල් වෙවි. ඒ ටයිම් එක 3/7.5. එහෙම ඉන්ස්ටන්ටේනියස් රෙස්ට් එකෙන් පස්සේ ආයෙ පල්ලෙහාට ඇදිලා එනකොට ඒ දුරම ආයෙ මෙතෙන්ට ඇවිල්ලා ලණුවේ දිග හරි ගැස්සෙනකල් මේ වෙලොසිටි එක හින්දා ගැස්සිලා මෙහෙන් ඉස්සෙන්නේ. මෙන්න මේ ටයිම් එක 9/15 ටෙස්ට් එක දාලා 0 ඉඳලා පටන් අරන් half 2.5 වලින් t square වලින් එන t එක. ඒ t එකයි කලින් මෙතන t එකයි එකතුව තමයි ඔයාට උත්තරේට එන්නේ. හරි. හා. Okay. මම මේ simplifications පෙන්නුවේ නැත්තේ මේකයි. I have to discuss the MCQs. Okay, I'm not going to stop from here. I'm going to discuss the MCQs. Okay. Okay, MCQ number 15 and then okay. Okay, Pude, I'll discuss MCQ number 15. I'm going to start from the MCQ number 20. I'm going to start from the MCQ number 20. Okay, let's start the MCQ discussion. Okay. Question number 20. This is a very interesting question. Nah? This is a very interesting question. This is correct. It's a correct question and it's a very good one. Nah? A 40 kg slab rests on a frictionless floor. Question number 20. This is a smooth floor. This is a smooth floor. A 40 kg slab. Weight is 400 newtons. It's on a smooth floor. A 10 kg block rests on the slab. A 10 kg block. Mass is 100 newtons. 10 kg block. This is the 40 kg block. Okay. The coefficient of static friction between the block and the slab is 0.6. Here you don't have a friction, it's smooth, but here Here you have a frictional coefficient. It's 0.6. Can you see? Here you don't have friction. This is on a smooth surface, but the common surface with this 10 kg and 4 kg masses, there's a frictional coefficient 0.6. Okay, and here the static friction is 0.6, kinetic friction is 0.4. Okay, the 10 kg block is acted upon by a horizontal force of 100 newtons, and here a 100 Newton force is acting on the 10 kg block. Can you see what has happened? So this is the 100 Newton force. This 100 Newton force will try to move the 10 kg box in a direction like this. In a direction like this. It will try to move this block in a direction like this. Due to that motion, there will be a friction created on this 10 kg block in opposite direction. Fg. Shall we find this friction first before doing anything? Now, this is the upper surface of 40 kg block. This is the upper surface of 40 kg block. On that block, there's a 100 Newton weight with the normal reaction R2, and there's a 100 Newton force acting on it to this direction. So there will be a friction on the opposite direction, Fg. Fg is equal to mu r. What is the limiting friction? What will be the limiting friction? The static friction. Mu s r. Mu s is equal to 0.6. R is equal to 100. Okay, then what will be the value? 60 newtons. So the highest friction that might occur here is equal to a 60 Newton value. And 100 Newton force is acting. So 100 Newton is larger than this static friction value. So what will happen? 10 kg will move. So kinetic friction will occur. What is the value for the kinetic friction? Mu kr. Mu k is 0.4. R is 100. 40 newtons. 40 newtons. So this friction value will be equal to 40. This value is equal to 40. I'll explain it again. Now, here I have drawn the 40 kg mass here. On the 40 kg mass, there's a 10 kg mass kept. I am marking the forces on the 10 kg mass. Its weight is 100. When it touches the 40 kg mass, there will be a normal reaction upward, R2. As a 100 Newton force pushes this 10 kg mass, friction will born in the opposite direction. Two frictional coefficients are given, mu s and mu k. What is the static friction? Mu s r, 0.6 into 100, 60. Applied force is larger than the highest friction, limiting friction, static friction. It's a 60 value, so 100 is larger than that. So definitely friction will get defeated and we will get the motion. When we start the motion, friction will suddenly change to its kinetic value, kinetic friction mu k r, 40. So we are applying a 100 Newton force on this 10 kg block to this direction, and there's a friction 40 newtons in opposite direction. So I come to my original picture, applying 100 newtons to this side, and there's a friction on this 10 kg mass in the opposite direction. Each and every force comes with the opposite reaction. So if there's a force, friction or whatever, in the opposite direction on this 10 kg mass, in the other side, on the 40 kg mass, there will be a 40 Newton force in the forward direction. I'll say it again. You are trying to move 10 kg mass in the rightward direction. So on the 10 kg mass, friction is borne to the leftward direction with the 40 Newton value. All the forces are borne with the equal and opposite reaction. So this friction, this backward friction on 10 kg can be considered as the force acting on 10 kg by 40 kg. So the reaction, force acting on 40 kg by 10 kg, it's in the opposite direction, in this direction. So even though this is a smooth surface, due to this frictional influence, now there's a 40 Newton force acting on the lower mass. Applying F equals ma for the lower mass, there's a 40 Newton force. Now mass is 40, acceleration is 1 meter per square second. The lower block will move rightward with the acceleration of 1 meter per square second. Lower block will move in a rightward direction with the acceleration of 1 meter per square second. I'll say it again. If the 10 kg block moves on the 40 kg blocks in the rightward direction, due to the 100 Newton force, friction will borne in the opposite direction. Static friction is 60, kinetic friction is 40. 100 is larger than 60, so the 10 kg will move in this direction, creating the kinetic friction 40 in the opposite direction. So each and every force is borne with the normal opposite force. Now this 40 Newton friction, how we can explain it? The force acting on 10 kg, the frictional force acting on 10 kg from 40 kg in this direction. So other component, force acting on 40 kg by 10 kg, it will be a same valued force in the frontward direction, 40. Applying F equals ma for this 40 kg mass with this 40 Newton new force, acceleration is 1. Okay, now okay. Question number 19. Question number 19. Now what happens? A painter is rising himself if and the crate on the which he stands with acceleration of 5. He is rising up with the acceleration of 5 meters per square second by a massless rope and a pulley arrangement. Mass of the painter is 100 kilograms, 1000 newtons, the weight. And that of the crate is 50 kg, 500 newtons. Okay. Now, to move up, string has to pass the pulley in an anti-clockwise direction, and the man has to push the string downward from here. When man is pushing the string downward from here, there will be an equal and opposite force acting on man's hand in the upward direction. It's a tension as the string is attracting the connected point toward itself. Tension will spread. Tension will spread and it will attract the roof of the vessel upward. Okay. Now applying F equals ma for the man and the cage. Applying F equals ma for the man and the cage. When man keep his leg in the ground, there's a normal reaction downward acting on the floor, and equal and opposite reaction, there's a force acting on man's leg in the upward direction, other R. So these are the forces. When I'm applying F equals ma for the man and the cage, what happens? On the roof, there's a tension up. On man's hand, there's a tension up, two tensions on the roof and man's hand. And R values are cancelled as we consider both of them. Weights 1000 minus 1000 minus 500. T upward from here, another T on man's hand here. 2T minus 1000 minus 500. Two R's are cancelled. Is equal to 150 A. 2T minus 1500 is equal to 150 into 5. 5 is the acceleration. 2T is equal to 1500 plus 2T is equal to 2250. T is equal to 1125 newtons. Okay, and now applying F equals ma for the man. Initially I applied F equals ma for the man and the cage both. So when I'm considering both of them, both of these R's are there, so they cancelled out. So I got a method to find T. Now I'm applying F equals ma for the man. When I'm considering the man, I don't need to consider the force acting on the roof of the cage. On man's hand, there's a tension upward. On man's leg, normal reaction is upward. The two normal reactions will not cancel out, as I'm not considering the man and the cage both. I'm considering only the man. So on his leg, there's a normal reaction upward. Tension on his hand upward. T plus R minus his weight 1000 is equal to 100, acceleration 5. T is equal to 1125 plus R minus 1000 is equal to 500. From here, you can have the value for R. Answer is 4. Force contact the painter and the floor is 375 newtons. You will get the 375 Newton value for this R. Okay, answer is 4. Question number 18. Okay, what's the situation in question number 18? What's the situation in question number 18? There's a mass here, a string passes over a pulley, and there's another mass. And two blocks A and B each of weight 200. Here the weight is 200. Here the weight is 200. Are connected by a massless string passing over a smooth pulley at rest. Inclination is 30. When it touches the ground, it will create a normal reaction like this. Here the angle is 30. Then A will remain at rest if the frictional force on it is. Now, a single mass cannot keep at rest when others are moving. Why? These two masses are connected by a string. If one is at rest, other is also at rest. This means they say one object is at rest. That means this complete system is at rest. Why? It's connected with a string, with an inextensible string. So if one is moving, other one also has to move from the other end of the string. So if one is at rest, that means all the system is at rest. Here the weight is 200 newtons, and if this is at rest, the tension up is also equal to 200 newtons. Why? If this is at rest, these two forces should cancel out. So this tension is 200. Okay, tension is spreads and it comes to here, and here also you will have a 200 Newton value. And 200 sine 30 is the weight component. 200 sine 30 is the weight component in this direction. And this is also at rest. To be at rest, this tensional force should cancel out with 200 sine 30 and friction to this direction. It tries to move in this direction, but friction will occur in the other direction. So if 200 is equal to 200 sine 30 plus friction, this 4 kg will also be at rest. 200 is equal to the other side, 200 sine 30 plus friction. 200 is equal to 100 plus friction. To do this, friction should have a value of 100 Newton. Okay, when one object is at rest in a system like this, other one is also at rest. Why? Both of them are tied by a string. So if this is at rest, the tension will be 200 to cancel out with this weight. So other side of the tension, this pulley, this mass is attracted up by a tension 200. So it will try to move upward, creating a friction in the other direction. But as they say, still the object is not in a movement. So this is also in equilibrium without a motion. So 200 should cancel out with 200 sine 30 gravitational call, and with the friction, 200 sine 30 plus friction should cancel out with in the 200 other side. To do that, friction should be a 100 Newton force, 100 Newton down the plate. Answer is 2. Okay, question number 17. Question number 17. A block of mass 5 kg, weight is 50 newtons, weight is 50 newtons. A block of mass 5 kg is placed on a rough inclined plane. The inclination of the plane is gradually increased till the block just begins to slide down. Now the inclination is theta. Now the inclination is increasing. The inclination is being increased. Now at this moment the value is theta. When it touches the surface, there is a normal reaction created like this. If the inclination is theta, here the angle is also theta. So to this direction, it's 50 cos theta. To this direction, it's 50 sin theta. So it tends to move downward. So the friction will create upward. Friction will create upward. And object is still at rest. Object is still at rest. So 50 sin theta. Angle is theta here. Here also theta. It's the gravitational call down the plane. 50 sin theta has cancelled with the frictional force upward, Fg. Why? Vertical forces can't affect the horizontal. So if this is at rest, 50 sin theta is cancelled with the upward friction Fg. 50. They say the inclination of the plane is 3 in 5. How to give the inclination? 3 in 5. Here 3, here 5. The ratio of the lengths 3 to 5. I have taught you the method of this inclination in a previous question. When they say the inclination from 3 to 5, so it's sin theta. 3, 5. 3, 5. Here it's 3 and here it's 5 sin theta. 3 over 5 is equal to Fg. So 30 is equal to the friction. Friction is equal to 30. Now again, friction is equal to mu r. Friction is equal to mu r. So it doesn't have a vertical movement also. So this r is equal to 50 cos theta. even though it's not having a motion in the parallel direction to the plane, and also there's no any motion vertical to the plane. So R is equal to 50 cos theta. Fg is equal to mu R. Fg 30 mu, as there's no any vertical motion either, R is equal to 50 cos theta. They have to cancel 50 cos theta. So 30 is equal to mu 50 cos theta. If the value, the ratio is 3 and 5, here it's 4. When you consider the ratios, if this is 3, this is 4, then here it will be 5. You know that. So what is cos theta? 4 over 5. As they have given this theta by 3 to 5 ratio here, the other leg it's 4. So the cos theta will be 4 over 5. Okay. 3 multiplied by 5 over, this 5 will cancel out this one, 0 with this one. 3 over 4 is the frictional coefficient. 3 over 4 is the frictional coefficient. Answer number 2. 3 over 4 is the frictional coefficient. Question number 2. Okay. Now I am coming to the 16th question. Question number 16. For the 16th question, most of you have marked the answer 3. Answer is 1. For the 16th question, most of you have marked the answer as 3. Let's see, answer is 1. Question number 16. There's an inclined plane at an angle with 30 with the horizontal. A block of mass 2 kg, the weight is 20 newtons, rests on a rough inclined plane making an angle of 30 with the horizontal. The coefficient of static friction between the block and the plane is 0.7, the frictional force acting on the block. Okay. Now, when it is touching the plane, there's a normal reaction created like this. If it is 30, here it's 30. So the weight is 20 newtons. To this direction, it's 20 cos 30. To this direction, it is 20 sin 30. 20 sin 30. And now, as it tends to move downward, friction will create in the upward direction. Now, shall I tell you how you take this third answer? What happened to you? Now you have marked the friction correctly and you mark friction is equal to mu r. Then what you did? You substitute the frictional coefficient 0.7 and you took the r value. There's no any vertical motion, so r should cancel out with 20 cos 30. You understood that. So as there's no any vertical motion either, this r should cancel out with 20 cos 30. From there you got the r value, mu 0.7 r 20 cos 30. Okay. 0.7 20 cos 30 root 3 over 2. Here 0.7 into 10 root 3. Okay. Now 7 root 3. That's the answer you got. But it's wrong. Can you see the problem? Friction is always not equal to mu r. Can you remember the theory? Friction initially is equal and opposite to the force we apply. 1 Newton, friction 1 Newton, 2 Newton, friction 2 Newton. Likewise, friction develops in the opposite direction with the same value equal to the applied force and keeping the object without any motion. And there's a value where the friction can increase while keeping its magnitude to the applied force. It's the limiting friction. From there onwards, friction is equal to mu r. But before that, friction is equal to the applied force and friction is in the opposite direction. Now, this block is asked to come down by a 20 sine 30 force. 20 sine 30 force. It's a 10 Newton force. What is this limiting friction value? Mu r, 7 into 1.732. It's a value larger than 10. It's a value larger than 10. So it's the situation. So what's happening here? When we apply a force on an object, the friction is created to the opposite direction. And initially, friction has the same frictional force value is equal to the force value that we apply. And it increases with the force we apply in the opposite direction, keeping the value same as the value that we apply. And friction will increase when we increase the applying force. Friction will increase in the opposite direction with the same value until the limiting friction value. After the limiting friction value, friction can't increase further. If we increase the external force we apply, we can bring the object to the motion. So that is the concept. The limiting friction is given by mu r. It's 7 into root 3. It's a value larger than 10. Okay. So until this 7 into 1.732 value force is applied on the object will not move. Until that, frictional force is equal to the force that we apply and in the opposite direction, keeping the object at rest until the limiting friction. Okay. So here the gravitational cold is 10. Object is not in a motion. Friction is also 10. Friction is also 10. Friction can increase up to its highest value, keeping its value equal and opposite to the applied force. We haven't reached that limit yet. Applied force downward is 10. So friction will also become 10, equal and opposite, object will not move. Likewise, friction can increase its value up to this point. If the applied force is larger than this, friction can't fight, friction will fail and we will get the motion. We are not at that situation, we are in the beginning. This is the 10 Newton 10 force, calling it downward. Friction will become always a value 10 and object will kept at rest. Okay, it's the question number 16. Okay, I'm going to solve the question number 15 now. I'm going to solve the question number 15 now. Okay, I'm going to stop the class from question number 15. Let's discuss the question number 15. මෙතනින් එහාට අමාරු දේවල් තිබුණොත් මැසේජ් එකක් දාන්න, නැත්නම් next week class එකේදී අහන්න. පිටිපස්සට දැම්ම අමාරු MCQ ටික. එතකොට ඒ ටික දැන් ඔන්න ඩිස්කස් කළා. ඊට ඉස්සරහින් කරපු જાති MCQs මයි තියෙන්නේ. new MCQ එක new concept එකක් enter කරලා නැහැ. තිබුණු concepts මයි තියෙන්නේ. practice වෙන්න ආයෙ පාරක්. ඒවයි මොනවා හරි problem එකක් තිබ්බොත් එක class එකේදී අහන්න, නැත්නම් message එකක් දාන්න question number එක. Hari? Okay, I'm going to discuss the question number 15. I'm going to discuss the question number 15. An airplane requires for takeoff a speed of 80 kilometers per hour. For the takeoff, it needs a 80 kilometers per hour velocity for the takeoff. The run on the ground being 100 meters. The mass of the aeroplane is initially at rest. There's no any argue about that. Airplane is initially, give me a minute. Airplane is initially at rest. After 100-meter distance, it has to gain a velocity of 80 kilometers per hour for the takeoff. Okay. The mass of the plane is 20,000 kilograms and coefficient of friction between the plane and the ground is 0.25. Mass of the plane is 20,000 kilograms. Frictional coefficient is 0.25. Assuming that the plane accelerates uniformly during the takeoff, minimum force required by the engine to take off is. Now, from 0 to 80 kilometers per hour is the velocity increment that it has to gain within a 100-meter distance. So it needs acceleration. Applying v square is equal to u square plus 2as. At the end, it needs 80 kilometers per hour velocity. You can't keep 80 into 5 over 80 is the final velocity that it needs. 80 kilometers per hour, you converted it to meters per second by multiplying it by 5 over 80. 80 into 5 over 80 meters per second velocity value at the end. V square is equal to u square. It's at rest in the beginning. 2 acceleration, distance 100. Okay. 80 into 80, 25 over 18 into 80. Here v square is equal to 2a, s is 100. So here it's 200 a. So 2 zeros will cancel out. Okay. Then here it's 4, 32 into 25 over 3600. 18 into 18 is equal to the acceleration. By applying v square is equal to u square plus 2s, I found the acceleration. Okay. Now I am applying F equals ma for the motion. So this F is the resultant horizontal force which gain this acceleration. Engine will apply a force Fe and the friction will be in the opposite direction Fg. When the plane is accelerating due to from the equations of motions to gain the velocity from a 100-meter distance, you got the acceleration needed. You have this now. Applying F equals ma horizontally, engine force minus friction is equal to ma. What is this F? F is the resultant force acting in the considered direction. What is the resultant force acting in the considered direction? Engine force minus friction. ma. What is the engine force? I don't know. And what is the friction? When an object is on the ground, when it tries to move forward, friction will create in the opposite direction. When the object is in a motion, friction is equal to mu r. Mu is 0.25. What is r? When the object is in a motion, friction is equal to mu r. Mu is 0.25. What is r? The plane moves in a horizontal path in the runway. So its weight mg has to cancel out with r there. Still, before the takeoff, let's consider that plane is moving horizontally. So the vertical forces should cancel out. So r is equal to 200,000. Weight is 20,000 kilograms, where the mass is equal to 200,000. If the weight is 20,000, mass is equal to 20,000, weight will be multiplied by 10, 200,000. As it's moving horizontally, r should have the same value to cancel out with weight. So r is also 200,000 and mu r 0.25 over into 200,000. 25 multiplied by 2000 . 50,000 newtons. Friction is equal to 50,000. So applying F equals ma for the plane horizontally, engine force in the frontward direction, friction in the opposite, 50,000 is equal to 20,000 A. A is equal to 32 into 25 over 18 into 18. Okay. From here, you can find the force created by the engine. Here, you can find the force created by the engine, 9.84 into 10 to the power 4 newtons. This is the situation. Okay. This is the situation. Okay. When the plane is moving to the forward direction, friction will occur in the backward direction. As it's in a motion, Fg is equal to mu r 0.25 into r. R is equal to weight, as there's no any vertical motion during the run. Weight is equal to 200,000. So find the friction. From equations of motion to gain the velocity after 100 meters, I found the acceleration. So when applying F equals ma, I know the acceleration and mass. It's gained by this resultant force in the horizontal forward direction, Fe minus Fg. From here, I know Fg, so I can subject Fe, the engine force. Okay. So these are the questions that I'm going to discuss today. And I have sent you all the marks and the remaining answers. If you have a doubt in a question that I haven't discussed, you can send me a WhatsApp message, or you can meet me at the class, and I will definitely teach you in both ways, through WhatsApp message or at the class. Okay. Now, next week, we are not going to write a paper. Instead, on next Thursday, we are going to discuss the two practicals. From the next fortnight, again, we will write the papers. Okay. So that's the plan. Okay. Then good night.